Everyone. Scott Rosenberg, and today we're going to talk about one of the things I love to talk about, which is just ranting on terrible practices. In my mind, that the industry thinks are good things, and I disagree. But one of those is this idea of shift left, right? And really, the idea of shift left came from good ideas, and we're going to try and talk about what the issues that shift left tried to solve, and then why that doesn't actually work and what we should be doing instead. So just a bit about myself first. So my name's Scott. I was born in Chicago. Been living in Israel for the last 19 years. As of this evening, it will be 20 years exactly. I'm the lead architect at the CTO office at TeraSky, solutions integrator. And been working in the Kubernetes world. Sysadmin, started from virtualization and have been in the Kubernetes world for about 5 years. And I like religious studies, whiskey, and Kubernetes and platform engineering exactly in that order. Those are my interests in life. So if we take a look for a second at what does shift left even mean? And we can take the CNCF glossary here, where shift left is the practice of implementing tests, security, or other development practices early in the SDLC rather than towards the end, right? And this sounds great. Why do we really want shift left? Well, shift left does solve a lot of issues for us. The idea of it was to find issues earlier on in the development lifecycle, which is a great thing. The issue is that shift left is a buzzword with no clear definition, like most words in our industry. Shift left means something different to every persona in every single company. It could mean something about testing. It could mean something about infrastructure as code, possibly. It could be security. It could be application deployment. It can be observability and a million other things, right? Shift left is a general methodology, but it is not exactly clear what that means, who we're supposed to be shifting left to, what should be shift left and what shouldn't be. And the only thing in common is that developers have increased cognitive load. Great idea when the people within the organization that actually make the money because they're writing the software, let's put more cognitive load onto them so they can focus less on code and less on actually bringing value to the company. If you ask me, that's an anti-pattern that we shouldn't be going towards. But why did we even move to shift left, right? And when we look at why we moved to this, it was for early bug detection. The earlier that we can catch things in the software development lifecycle, the better it is, and the quicker we can fix them, right? One of the biggest issues was, and still is in many companies that don't use shift left methodologies, is that we're going to go and, I wrote some code, pushed it up, a week later it gets run in some whatever, there's QA testing that's happening, and someone comes back to me a few days later or a few weeks later and says, hey, there's an issue in your code once it reached higher environments. And it's like, okay, now I need to spend half a day just to remember what I wrote a few weeks ago to try and figure out where the issue is. And we do this context switching, which takes a lot of time. Another thing is to improve the software quality. The quicker we do tests, the more we test, the more we add security earlier on, we can build better software, and we don't end up just doing hacky patches on top of the things we built just to get it out the door. It's faster time to market was one of the claims behind shift left, which many times is actually a fallacy. But the idea of faster time to market was that if we can catch these things earlier, we spend less time doing this context switching back and forth, we can get to the market much quicker, we can release software at a faster pace. Also, it can be cost efficient because we don't need DevOps people anymore, which are just IT operators that found a new title to add a zero to the end of their salary. But that's the thing with cost efficiency, is that we say, great, let's just put it onto our developers. We don't need as much DevOps, platform engineering, SRE teams. We can just give more responsibility onto our developers, save money. And the biggest one, and this is the only one that I believe is actually true, it removes IT as the bottleneck. Because IT are always viewed as the bottleneck, whether we like it or not. I grew up as a VI admin, as virtualization infrastructure, but always IT are to blame, and we're always the blocker, because it's send a ticket, and great, you'll get a response in 3 days. And this was a terrible approach. So by shifting left, letting the developer deal with these things for us, we actually solved a lot of issues, or that's what the claim of shift left was. The real issue with it, though, is something that Kelsey mentioned a few years ago in a great tweet of his, that I think we are asking developers to do too much by shifting everything left, including security. While it should be a collaborative effort, the idea that developers need to become security experts in addition to everything else just isn't sustainable, right? We keep going with this idea of separation of concerns, that there should be different concerns for each persona who actually know what they're doing. They're experts in their field. There are security experts, observability experts, infrastructure experts, cloud experts, Kubernetes experts, development, which we need our own levels of expertise. And by just shifting things to the developers, we're not actually solving an issue. What we're going to end up is one of two things. Either our developer is not going to focus on writing code, or the other option is we're going to get subpar security. So we can choose which way we want to go, but with shift left, we have to make some compromise. And if we look at a few of the challenges in general, it's really a skill gaps issue, right? Developers do not know everything that is needed for security and for testing and for infrastructure and infrastructure as code and all these different elements that we're trying to shift left to developers. They also have an increased initial workload just to get that hello world application up instead of the 3 lines of Python code or 17,000 lines of Java code, depending on which language you write for a stupid hello world application. It's now much longer because they have to add in all these different elements from the get-go, making that initial workload much higher. There's also a lot of cultural resistance. And this coming from an SI where I work with different companies all the time, we see this on a daily basis. The cultural resistance from these shift-left moves is enormous because the developers want everything to be fast, but they don't want, on one hand, the developers, they really don't want the extra responsibility. They want the privileges, they want the good side, but they don't want the responsibility. And on the other hand, IT and the operations teams don't want to give up the control to the developer because then they feel that their job is being at risk here. So we have a general issue here of cultural resistance, and tooling and integration is one of the biggest issues as well. Security tools were built for security operations teams who are traditionally people that like using UIs and who like using different wonderful systems that are not the places where a developer wants to live, in his IDE, maybe an internal developer portal, and within source control. That's where they want to live. They do not want to live in 17,000 different tabs of security tools, whether that be the Prismas, the Aquas, the JFrog X-Rays, whatever tool they're using for security. That's not where a developer wants to live. We have to always balance also speed and quality, right? Getting things out, or do I want actually quality things to get out? And that's a big challenge as well. And the lack of separation of concerns. Now, before we get into how we fix all of these issues, I like giving a small metaphor here of what does shift left, what are we basically doing? And we're basically saying, hello, Mr. Plumber, you're pretty good at installing pipes in unfinished walls of our new house. It's kind of hard to schedule the drywall guy to show up the moment you're done. Sometimes the delay causes schedules to slip. So maybe it would be better if you did the drywall also. And while you're at it, why don't you also paint the wall? Because then I don't need to schedule the painter to come, which is also good. But don't worry, you're going to still be paid the exact same amount and be given the exact same amount of time as if you were just installing the pipes. And that's basically what the shift-left movement has done in our industry. Let's move more things onto developers. Let's give them all of this, but not allow them to grow the amount of time that a task is going to take. We're going to shrink their timelines even because we have to get to market faster. And they have to do 10 times the amount of work in things that they are not experts in, nor should they be. And this is the real challenge here. So what is the solution? And something, a term that I coined a few years ago of shift down to the platform, which instead of shifting left to our developers, which adds a cognitive load, what we should be doing is shifting down to the platform itself. And this is where the whole idea of platform engineering really picks up, not in the buzzword term, but trying to bring it to an actual reality. And shifting down to the platform addresses this by, instead of shifting the responsibility to another persona within the organization, let's shift it down to the platform itself, to the automation, to systems that can actually deal with these things for us instead of shifting it to another person and just say it's someone else's problem. And let's see a few examples of what this looks like in organizations and where we're seeing the success or the failures of shift left and how this different approach could help us. If we look at the shift left approach, developers scan code using IDE plugins or CLI-based scans, right? In the shift down approach, developer pushes code to Git and the code is scanned automatically. Now, we could say, hey, why not do both? And you can do both. But without having it in Git, we end up with the issue of shift left of, is the developer actually going to scan his code? Or is he not going to scan his code? Did he forget that step? Did he not forget that step? Which version of the scanner is he using? By shifting it down to the platform, we raise our quality and we don't add extra steps for the developer to perform on his own. We can do those as pre-commit checks, for example, in Git. Developer receives a list of all found vulnerabilities in their application and must manually check and research which of the vulnerabilities is applicable to their application. One of the greatest examples of this is Kotlin, a interesting framework or language. But Kotlin, I have a few customers that I've worked with that run Kotlin applications on Kubernetes on x86 architecture. But 90% of the vulnerabilities you'll find in Kotlin are relevant for when running on ARM processors on the Android operating system. So they end up getting a list of, hey, you can't go to production, you have 98 critical vulnerabilities, when 0 of those are actually applicable to their application and where it is planned to be run. And we see this nonstop. We see this in Go, between ARM or x86. We see this challenge all the time. And in a shift down approach, developers receive an auto-generated VEX document. The industry has come and said VEX documents, which the vulnerability exploitation exchange or something like that. I just call it VEX. But VEX documents basically come and say, based on the runtime, what is actually vulnerable? What is loaded into memory? What isn't loaded into memory? What is applicable based off of the runtime architecture or not? And then a developer can get this VEX document and say, perfect. I know exactly which vulnerabilities matter here. Another one is developer must remember to run security and testing steps early in the SDLC versus automating that in the platform on push, right? This is something that many of us are already doing when we push to get a commit, all of a sudden this happens. But this approach is, also fits into this move away from a shift left style of methodology. Developers need to understand low-level cloud constructs. This is one of the worst things in the world when we see tools that, in my mind, just don't make any sense. Things like Pulumi, where it's actually infrastructure as code and not infrastructure as config, where it comes to the idea of, great, let's have the developers write infrastructure as code. Developers know TypeScript, they know Python, they know Java. Wonderful, let's have them write infrastructure as code. The issue is they don't know the infrastructure side, so the code that they're writing makes no sense, because when you write code for something you don't understand, the code that you are writing does not make sense. And that is a general issue. Infrastructure as code is meant for DevOps, and DevOps understand YAML, whether it's crossplane, which I'm personally a fan of, or if you want to suffer through HCL, you can use Terraform. And there are many different options here, but this is a general issue that we have of developers needing to understand these low-level cloud constructs. If they want to bring up an EKS cluster, good luck learning all 32,000 resources you need to create a simple EKS cluster in AWS. It's just not feasible. In the shift down approach, developers are given a self-service portal or an API through things like compositions and crossplane to easily consume whatever high-level service we care about as the platform team that we have offered. That could be database. Now, they don't care if it's RDS or if it's Azure Managed SQL or if it's a Bitnami Helm chart or if it's an operator from Operator Hub. It doesn't matter, because all we do is expose to them the few fields that they actually care about. And then they don't need to care about what all of that means of what a DB subnet group is, what a subnet is, and what an RDS instance is, and how you hook all this up, and how you set up KMS in order to encrypt it. So we can codify all of our best practices and only expose to the developers the things they actually care about. What version of Postgres am I using, for example? Developers also need to create Docker files. Terrible approach. Red Hat, VMware, Google, many companies have come and realized this and created technologies like build packs or like source to image, where give me source code and I will build an image for you. And that is another key approach here because Docker files should not be maintained by developers. We have better systems that can do that, including things like Kpack with build packs, source to image in OpenShift, and things of that sort. Developers also need to define resource requests and limits. This is one of the biggest issues we see in Kubernetes, setting requests and limits. The infrastructure team don't know the application, so they can't set the requests and limits. The application teams don't know anything about infrastructure, so they can't set the requests and limits. And the way it ends up going is, I think 4 gigabytes makes sense, and the application is actually using 100 megabytes at peak time. And it doesn't make any sense, and as good as Carpenter may be, or Cluster Autoscaler at autoscaling our cluster, it can only base itself off of our requests and limits in Kubernetes. So as bad as they are is as bad as our cluster autoscaling is going to be. And typically what we see when I've been going to different customers and doing different benchmarks and health checks on this, is we see typically 75% wasted usage in requests. Within the standard clusters, that's the medium. I've seen up to 92%. Because also developers make the small mistake and put 8 GI instead of MI, and we see extra zeros added sometimes. And once I saw someone with 80 gigs on a Apache web server because they needed 8 gigs, and oops, a 0 got in there. But that happens. And that's an issue. When we look at the shift-down approach, resource management is automated. There are great tools in this area, things that wrap around VPA or completely separate tools, such as ScaleOps or other tools in the industry today. There are Turbonomics. There's many tools in this area that come and automate our resource requests. They look at metrics, historical data, and they will set the requests and limits at runtime as they should be. Don't make the developer figure that out. IT can't figure it out, so just let the platform do it for me. We can solve our issues. Developers also start writing new microservices from scratch. Typical issue we see, how long it takes to get started writing a new microservice versus software templates, application bootstrapping, where we can start with actual good bootstrap code. Now, let's take a look at a few examples here, though, that really help us. So in the industry, we have a great tool called Kubescape. Kubescape helps us automatically generate Vex documents based off of every pod running in our Kubernetes cluster and exposes it either via an API, directly in a CRD, or there's also commercial products on top of this. I think one of them is called Armo, that basically expose this in the UI. But the idea is we can get automatically generated Vex documents for any pod running in any cluster, so I can get my vulnerability data automatically without any extra work from any team here. Harbor, a great image registry that can scan images on push, prevent running images that have vulnerabilities, with one of the benefits being it's a pluggable scanner. Now, why does that matter that it's a pluggable scanner? Because while we want the image registry, we want on push to automatically scan and then enforce policies, security teams, they have opinions. And they don't like being told that their opinions are wrong or that they need to change them. So if the company is using Prisma, they want to use Prisma. If they're using Aqua, they want to use Aqua. If they want to use Claire or Trivy or Gripe or Encore or any scanner, they want to. Most image registries have this capability already, but it's tied to a specific scanner. So if that's not the choice your security team made, then it's a very hard pitch. If you have one that has a pluggable scanner, that becomes a huge value, and it is a graduated CNCF project. We have Sneak, the first tool, I think, in this industry that actually did this, with the automatic PR generation where it scans your Git repos and creates PRs for you with fixes. That is, let the platform deal with that for me instead of going to the developer and say, hey, please, increase your vulnerability, increase the versions to fix certain vulnerabilities, or things like Dependabot also work in this area, but Sneak really helps more from the security perspective. We have things like software templates and Backstage, right? Backstage in general, but also software templates in particular really help with this shift-left approach the shift-down approach, with let the platform automate these things and don't put the burden onto a developer to figure out how to start writing a new microservice. Guide them through a simple UI, through a simple form in Backstage, for example. Kpack is one of my favorite tools in the Kubernetes world, which is a Kubernetes build platform, which uses build packs and allows us to automatically rebase images. It allows us to automatically build images and do what GitOps tools like Argo CD and Flux have done for continuous delivery, it does the same thing for RCI for building container images. Watches a Git repo. Anytime that happens, it builds it, pushes it, and it's also level 3 compliant with its integrations with things like in-toto, attestations, and cosign. So really powerful. Another tool would be something like ScaleOps, automatically fine-tuning resource requests based on real-time data. A game changer in the sense that developers don't know what to do, IT don't know what to do, and this solves that for us. Now, Pixie is another amazing tool in the observability space. From New Relic, it's open sourced, and what Pixie does is it does auto instrumentation and observabilities for your applications. It actually uses OpenTelemetry, and it can pull in data from OpenTelemetry. But the benefit is it actually runs as an eBPF process within Kubernetes, and it does auto instrumentation and profiling with 0 changes in your code. You don't even need to add in OTel into your application. Now, this does have a subset of languages that it works with and whatnot. It works with Java, it works with Go, it works with .NET. But the idea is that we can get huge amounts of application insight with 0 work from the developer. Now, that doesn't mean that the telemetry, when we instrument it ourselves, isn't going to be better. But the fact that we can start from a really good baseline with 0 work is a huge benefit that we get here from a tool that, with adding the profiling capability, adds about 0.5% overhead of 1 core on a node, which is basically nothing. On the other hand, if you go and add profiling, if you enable profiling on a Go process within containers, and you do that at every single container that you're running, it grows exponentially. This is 1 time per node versus per container adding that profiling, which ends up getting much, much larger, and our overhead grows exponentially. Crossplane is another great example of defining custom APIs to expose them to our developers. So if we take a look at some of the key takeaways, really, shifting down to the platform enhances security. It lowers the cognitive load on developers by having the platform actually deal with these things for us. It can be implemented in phases, which is critical here. Any of these tools can be implemented on its own, meaning it's really easy to make these changes within an organization that you can start with 1 tool. And you automatically gain that benefit from 1 tool. Because they are all separate tools, they also integrate very well into existing workflows, and it's not a complete tear and replace. It also can help with standardization, because when it's moved to automation, we get standardization. We don't get developers running random things differently. And it can be much more cost-effective and efficient, because our developers actually focus on writing code, which actually brings the company money, and we can actually deal with everything here in a much better way. So thank you, and are there any questions?
Yeah, so I noticed that you didn't cover DevSecOps framework or DAS, SAS, IAST, RASP, having developers having access to like check marks and SonarQube, so that instead of a frequent back and forth between the security department and the developers, you can actually have the developers constantly looking and saying, okay, this is vulnerability assessment, this is vulnerability management, risk management, where you can actually see what's happening real time, where vulnerabilities are and how to address them, and thus have a quicker time to production.
Yeah, definitely. No, it's a great point. That's really where Backstage comes in, right? Because Backstage, one of the issues is if the developer has to go to checkmarks, has to go to SonarQube, has to go to Sneak, has to go to 10,000 different UIs, the answer is they won't do it, even if they were given access. But if we go down the approach of, great, have the internal developer portal, have their component page, which has all of this data generated in one place where they can view it all, that is something that they would want, right? No one wants to learn 30,000 different UIs. But if we have everything integrated into Backstage, then all of those tools can be visualized by the developer in a really seamless way, right? And that's where Backstage really comes in. I just didn't get into that, you're right. But it's really a key element, I think, of that internal developer portal, is to have that single UI for a developer so we don't have to do with that context switching continuously.
as someone currently in the throes of guiding a rather large organization through a platform engineering journey, going from kind of a shift left, actually, I would even say less shift left, more of there is a black box over there that we toss code into and product or service appears out the other side. As we move towards a platform engineering space, what are the largest challenges that you've observed, and any suggestions on how to vocalize the abilities and capabilities of moving towards a platform engineering and foundational model? The shift down models exactly what we're trying to do. And a lot of what we're finding is breaking habits can be difficult. And there's always resistance to change. We've always done it this way, and we've gone on a lot of road shows. So when it comes to communication, I guess what is your advice? What are your experiences in that space? Any tips from someone who's gone through it?
Yeah. So I've gone through this with a bunch of different organizations throughout the years, and there's a few things that I'll mention here in short, and then if you want, we can also talk afterwards. But the main things are many people try to build that platform, and it takes them 1.5 years to get it out because they try to build something so large and so magnificent that solves every issue that by the time they get it out, 90% of that is antique and not relevant anymore with how fast our industry is moving, and it becomes impossible to maintain because you built something so big. The biggest mistake we see is platform teams that don't actually talk to developers. And that's about 99% of the cases where they think they know what the developer wants, so they build the platform, but they never actually ask the developer what he wants. And in 100% of cases, that does not work. So you have to talk to the consumer and bring them in early. It's always start with 1 or 2 teams that are friendly teams of developers to start with you on an MVP, figure out what that key issue that they're suffering from, 1 or 2 issues, solve those, get them on your side, and once they're on your side, they will start evangelizing as well within the other development teams. Because if IT go to development teams, unless they're a friendly team, they're not going to listen. But if another development team comes to them and says, hey, look at this, look how awesome it is and how easy I can consume these services, then they get interested. They usually listen to development teams more than IT. So really try and get that 1 or 2 teams in, and don't try to build too big of an MVP.
We probably have time for a couple more questions because it's a break time now and we started a little bit late, so we can have a couple more. Or you want coffee?
Thanks.
Awesome. Thank you, Scott.